Here's a quick concept for my listeners, those who have been paying attention for quite a long time. There's an elemental mass equilibrium in stellar metamorphosis. Now, elemental mass equilibrium can be applied to many different elements. Two of them in particular I discuss in this paper are hydrogen and iron. Basically, what it means is as stars age and they cool and collapse, and the more volatile elements leave, and some of the volatile elements combine with other elements to make heavier and heavier molecules, the amount of heavier elements stays in proportion to the lighter elements that have escaped, such as helium and hydrogen and oxygen and nitrogen and what have you. So when astronomers mention that the stars are mostly helium and hydrogen, we know that that's not necessarily true. They're missing a contextual truth in that young stars have mostly helium and hydrogen, which is counter to obviously a lot of the Big Bang pseudoscience that is currently taught in today's astronomy and astrophysics communities. Hi, Celeste. Now, the amount of hydrogen and helium inside of young stars is a lot higher versus iron. So there's very little iron. So here's a little handwritten graph here. It's pretty sharp. So the mass percentage of hydrogen in young stars is over here, and that's iron down there. And as the stars age, that percentage drops for hydrogen and increases for iron. So there reaches a point in a star's evolution where that ratio of iron to hydrogen matches each other in terms of mass, not molar amount of atoms, such as Avogadro's number. That number can match too, but I'm talking about specifically mass. So hydrogen is a lot lighter than the iron, but their mass is going to equal each other, and then that ratio is going to continue on as the star continues aging, and there's going to be more iron. Eventually, the hydrogen is going to drop off altogether as an element per se. Of course, it's going to combine with other elements, and there's going to be less of it, and the iron percentage is going to rise. Now, this also plays into part even when the object becomes solid. So, for instance, you have Earth, which has a lot of oxygen and hydrogen, which is combined with other elements to make other molecules, such as rock, that compose rocks and minerals and in the atmosphere and stuff like that. But you have a large iron-nickel core in the center of the Earth. And the outer areas of the Earth, the mantle, as it solidifies and cools, you're going to have the surface of the Earth eventually disintegrating to outer space, and it's going to eventually erode away over tens of trillions of years, similar to what's happening to Mercury right now. That's why Mercury is trillions of years old. And eventually that iron core is going to be left over and just going to be a little ball wandering around. It has very, very little hydrogen and helium in it, and the majority of the mass is iron. And we see one of these dead cores that we're going to go visit called 16 Psyche, Psyche, and we're going to orbit it, and we're going to find out that that thing's probably just mostly iron and nickel and some silicates. But what you're looking at there is the very inner core remains of a long since destroyed world, long since destroyed star that is countless of quadrillions of years old, most likely. And they're going to try to date the surface, and they're going to try to make it conform to the Big Bang pseudoscience, but that thing is so incredibly ancient that it's beyond comparison. And this being said, that also plays in the part to the Krypton hypothesis that I wrote about earlier, where when you have a star completely disintegrating, and you'll have deeper and deeper material disintegrating, eventually entering in the atmosphere of another star in terms of, or in the form of small rocks and small pieces of it. In other words, the meteorites that you hold in your hands if you ever have one or ever bought one, those are pieces of the core remains of a long since destroyed world. So you don't necessarily need to send a probe up to 16 Psyche. You can see the inner remains of long since destroyed worlds in terms of the meteorites that you can hold in your hand. And if they're very pure iron nickel alloy, then those are the very center remains of a long since destroyed Earth, which goes hand in hand with this mass equilibrium principle. So the more iron there is in it, it's just really old. It's had all that time to be ripped to shreds and to collect in the galaxy, in the universe. And for those who don't know, the ages of these objects that we look at in the night sky, the sun I only have is between 8 to 13 million years old, which is counter to a lot of the ideas that they currently teach. It's not as old as the Earth. It's very young. I have Mercury is 7 to 21 trillion. I have Earth is 4.5 billion. That seems about correct. Venus is 700 billion. Jupiter is 700 million. Saturn is 550 million. Neptune is 1.2. Or what was that? Uranus as 1.2, and Neptune as 1.1 billion years. Those are billion years. And what you'll see here is obviously there's a huge difference in age. The very young objects are very large. They have a lot of helium. They have a lot of hydrogen. They're not fusing matter together. I don't know why that idea is continually taught, but basically that really wraps it up for this talk. I'll link this paper to the bottom so people can read it for themselves. Alright, later y'all.